Welcome, South African Grade 9 STEAM cadets, to the Academy's Neon Lit Engineering Lab. I'm ProfessorL, and, well, we have a bit of a situation. Our main security system is completely down, and I'm going to need your junior circuit engineer skills to help fix it. Let's dive right into this explainer and get this place secured again, shall we? Okay, so here's today's mission briefing. We need to decode Worksheet 3B. We're going to read through these glowing circuit blueprints and get this alarm operational. And look, we're not just memorizing answers here, right? We are thinking like real engineers, figuring out exactly what the CAPS examiners are looking for. So are you ready? Let's go. Right here in front of us is the master blueprint for the broken alarm circuit. You can actually see the electronic components. They're labeled A through F, with the current flowing directly from our 9-volt battery pack. But here's the catch. To fix this thing, we really need to understand what each of these parts actually does. All right, it is time for your first cadet challenge. Go ahead and pause the explainer right here. Look really closely at component F. What is this specific one-way component called? Hint, think about what might give us a bright visual warning in the dark. Okay, if you guessed LED, that's light-emitting diode, absolutely excellent work. It basically acts like a one-way street for electricity, and it gives us that flashing visual alert to warn us of any danger. Oh, and here's a quick examiner tip for you. Always mention that a diode allows current to flow in only one direction if you want those full marks. Let's build on that. Time for another cadet challenge. Pause right here and examine component C. It's that little rectangular symbol sitting directly above our LED. What do you think its job could possibly be? Spot on, cadets. It is a resistor. Think of a resistor as like a speed bump in our circuit. It slows down the flow of electricity so our little LED doesn't just burn up from getting too much current. Seriously, imagine trying to take a sip of water from a blasting fire hose. That is exactly what happens to an LED without a resistor. Now, knowing this prepares us perfectly for question 3.12 of your mission. Take a look at these two alternative circuit designs. We've got circuit A on the left and circuit B on the right. They look pretty similar, right? But if you look closely, they actually have one massive difference right at the start of the circuit. So here's your next challenge. Take a brief time out, pause, and think like a true engineer. What are the input devices, the sensors, in these two different setups? Look really carefully at those symbols sitting right next to the 10 kilo-ohm labels. All right, let's check your intel. Circuit A uses an LDR, which is a light-dependent resistor. A fun way to remember it is Larry LDR. More light equals less resistance. Circuit B, on the other hand, uses an NTC thermistor. That's a heat sensor where the resistance drops when things get hot. So one detects an intruder flipping on a light, and the other detects a fire. Make absolutely sure you use these exact terms in your worksheet for your Grade 9 technology exams. Time to test those observation skills again, cadets. Look over at the far right of the circuits. What are the two output devices, shared by both setups, that will actually alert the Academy if there's an intrusion or a fire? Pause and think about it. Did you spot them? Both circuits use an LED for a visual flashing alert and a buzzer for a loud audible alert to scare off intruders. Having simultaneous outputs is super important. It ensures that absolutely everyone, including people with different hearing or visual abilities, is warned immediately. It's just smart engineering. And that brings us to, honestly, the most powerful component in our whole system, the true body card of the circuit, the transistor. It takes the tiny signals from our LDR or thermistor and does something absolutely incredible with them. You see, the transistor has two main superpowers. First, it acts as an electronic switch, which is turned on by a really tiny current from our sensors. Second, it amplifies that electrical signal to make it strong enough to power our heavy-duty outputs, like that loud buzzer. If an examiner ever asks for its function, always write switch and amplifier to secure those full marks, every single time. Okay, let's test your true engineering comprehension with a final mission challenge. I'm going to start taking away pieces of our system. Before I reveal the answers, I want you to predict what happens if we completely remove certain parts of our circuit. Let's see if you got it right. If we remove the 9-volt battery pack, well, absolutely nothing works. There's just no power source to push the current. Makes sense, right? And without a switch, we simply can't open or close the door to control the current flow. We would literally have no way to arm or disarm the alarm system. Now, what about the other parts? Without a resistor, like we said earlier, our LED gets way too much current and just burns out in a puff of smoke. And without a buzzer, our alarm becomes completely silent, which means we fail the mission entirely. Every single component has a critical role to play on this team. Now lean in closely for this part. I've got some highly classified cadet intel to help you answer Worksheet 3B flawlessly. Examiners really love to catch you on a few common mistakes, so listen up. First, don't confuse the light and heat sensor symbols. Always check the specific shapes inside those circles. Second, remember the transistor's dual superpowers. It's a switch and an amplifier. And finally, never forget that a resistor must always be connected in series with your LED to protect it. Got it? Awesome. All right, let's debrief our mission. We've officially mapped how the current flows through a complete circuit. We saw exactly how those input sensors detect light or heat changes to trigger the transistor. And we learned how our visual and audible outputs activate at the exact same time to keep the Academy completely secure. Really excellent work today. Congratulations, Team Cadets! You have successfully restored the Academy's alarm system. Just look at it glowing back to life. Remember, every lesson is a mission, every learner is a STEAM cadet, and every great engineer starts with curiosity. Learn, create, innovate. I'll see you in our next mission. But hey, before you go, I want you to think about this. If you could add just one more sensor to this Academy alarm system to make it completely unbreakable, what would you invent?